Hi, Alex. How are you?
Hello, good Friday.
Friday, yeah, same for me. So Alex Polaros told that he cannot join.
Okay.
So let's discuss what we have to discuss and we can document afterwards.
Yeah, correct. So the main idea was that we plan to build the Redis implementation for bulk operations. So to write, okay, the initial idea was to write the status operations to Redis and then read them also from Redis. So we excluding the Magento database on this step, which giving us speed improvements, which is quite good. But still on this step, we have the database connection open. So there is still SQL queries are coming in and out from the database, which generally for this task, when we create a new API request to Magento via the bulk endpoints, we don't really need a database of Magento because we have all data coming with response and we can just put it in a queue, which configuration is stored in etc environment PHP file. So an idea was that in this step, we can, if we will exclude Magento database, it can be multiple times faster just using the Redis on these endpoints. We already made the performance test some time ago for the way when we exclude the database slot for operations test statuses. And that was, that was in any case good speed improvement on this step. But I honestly don't know what else currently is loading on Magento instance when you're doing this request.
Mm-hmm. Yeah, so first of all, performance test indicates that it will be at least twice faster for any given asynchronous API request to write message to the message queue in case if we exclude database. So it was very simplistic performance testing. First, we just did raw asynchronous requests, load testing, like 1,000 concurrent requests to Magento backend. And we measured how long did it take to get a response for every request. And second was just a piece of the code which removed writing to database and reading from database, and same test. So it was 16 seconds versus 15 seconds, so twice faster. Regarding where we need database requests, so first of all, like you mentioned, it is status of the bulk API is written in database on every bulk request. So we kind of take the bulk request, asynchronous request, generate the bulk ID and write that to database and write the status of that request. So later when we process the request, we can correctly report the status. Second thing is Web API framework itself requires database connection to read information about Web API user, which is loaded from database based on the authorization token. We kind of parse the token, take user ID, load from the database the correct user, and then make request in context of that user so that you can check permissions, you can check different things. The second thing. And third thing is the most important one, and the one which causes the biggest load on database during the API request is deserialization of the data. Every time we make API request, regardless if it's synchronous or asynchronous, in order to deserialize the array of attributes, we read the database and we read a metadata for EAV attributes. So we know which attribute belongs to a particular entity. For example, for product, we load all product EAV attributes, then deserialize the data, and then we know that this particular field on the custom attributes on the product is actually EAV attribute and is a valid attribute. And we also read some additional metadata information which helps us to understand the type of the attribute. So I think the two biggest things we can attack right now is first don't write status to database. For that, we have discussed that we can use Redis and correctly display statuses, just writing them, writing the bulk ID of operation to the Redis and having correct status there reflected. And then every time status changed with atomic operation on Redis, we can update the status so that it will always be correct. And second thing to attack is EAV attributes. So if you look at why we need to read database, this is only because EAV attributes can be changed dynamically by admin user when he add or remove particular attributes from particular entity, like from product. But it turns out that those data can be effectively cached. So we can cache data about EAV attributes and all metadata because we already have triggers to remove the cache in case if somebody changes the structure of EAV.
I have a question. Is it really required to have it on this tab, or cannot we move this logic for the worker already? So we just write to queuing system the request which we received, and don't care about the product attributes, and then make all validation and on another side.
Yeah, potentially it can be possible. So that was first idea we discussed. However, it will not solve the same problem for a web API. Like if it is a synchronous request, you still do the same. But there you don't have a place where you can move this logic because everything is synchronous and happens in one request. Mm-hmm. But if you actually fixed the way how we deserialize attributes for web API, it will make a good performance improvements both for synchronous and asynchronous APIs. And why we need to deserialize the data and why we need to load the metadata? Because we want to validate that data came correctly. So we don't have any fields which does not belong to the entity, or we have all fields which are required for the entity.
Yeah, correct. May it happen that if we cache those field structure, that's something where, yeah, okay, if something where change the cache is updated, then it's fine for us?
Yep.
Okay, yep. If cache is disabled, then the general should not happen on production system?
Yeah, because if cache disabled, we just fall back to previous approach where we deserialize everything in runtime.
Correct, yeah, like default behavior. This case. Correct. And I'm not sure. I mean, now currently we are not caching EAV structure, if I remember.
No, we don't. So actually, if you try to profile the web API requests, first thing you will see is that it reads database to read EAV information.
Correct. So then this means what we have to think about that put EAV structure into cache.
Yeah, I think it will be ideal to start from some prototype where we can, first of all, cache EAV structure, then invalidate EAV structure once changed from the cache, and then use cache from the web API serialization and deserialization. So this are three most important things to investigate how it can be done.
Yep.
And second, a little bit less important thing to investigate is how much performance gain do we get out of it. Because why it's less important? Because we already see that it will give us performance gain, but exactly how much we don't know.
Yep, true. I mean, if we for last test, I excluded only operation table, which is only one database table, which right and then back, it was already a big performance improvement. So if we exclude the whole AV tables from out of it, it's have to be really cool.
Yeah, the only thing that there for status we have write operations. Here for EAV we have read operations. However, we have just one write operation for status, and it's around like 50 read operations for EAV. So there are a lot.
True. What about object types? I mean, should we cache all object types?
I would say yes. That should be like it should be it should work the same for every object basically. So every object should be serialized the same way and using same cache capabilities. Because in future we might decide to expose as API any object in the system. Or even for new objects, like if you introduce some new entity, some new API, that ideally should be cached as well, if it is EAV.
Yeah, correct. And we're talking only about EAV object.
Correct. I don't think we have this problem for any other objects or for any other attributes, like extension attributes. They are read from reflection, and reflection is cached.
Good, yeah, that sounds good. So, yep, we have some tasks to do. So, check how we can put a structure into cache, validate, and use it for web API. So then I'll make some stories out of it in our backlog.
Yeah, so we need to have the stories and tasks, and you actually can ping Misha, he can create those stories, just let him know that we need that, and all that.
Good. That's good. Okay. So yeah, then I would propose I will go through the stories, I will formulate them. I also will generally, we have already a story for Redis. For operation status, I would generally extend it because it's too general. I would maybe make at minimum 3 different stories out of it, the small issues. Then each new developer, each new contributor can start with something small, like add key value library or add Redis library, kind of this. With a clear description that will be nice, and we will have a pack of the tickets for everybody who is interested.
Yep. And also we are starting performance track, and the track will be dedicated specifically to removing the number of queries for any Magento page. Like if you load homepage and you see like 20 queries, but you want to have 1 query, this will be the part of the project. So for our specific case, it intersects a little bit. I think we should track this work here because this is important for bulk API. Sure. However, if we see contributors and they were looking for what to contribute additionally to performance track, that will be also one of the options.
Yep, sounds good. Okay, good. Then for now, fine.
Okay, cool. Thanks a lot for this call. See you next week.
Thank you too. That was nice. I mean, if we'll create a good backlog, hope we will get more interest.
Yep. Okay, have a good weekend.
Yep, you too. Bye-bye.
Bye.